Today we want to integrate things that may involve the use of trigonometric substitution, even though per se it may not involve a trigonometric substitution. That is to say, something that may involve something in the integral.
I don't even care.
You don't share either.
I don't even care.
That's so adorable.
I gotta drop it. Take too much of my life away from me. It's not smart. I do.
If the integral involves something like this in the integrand, then it may involve having to use a trigonometric substitution. Even though the integral itself may not appear to involve trigonometry. Now, when you make these substitutions, you will have to make a triangle. And we are all experts on making triangles. And once you make your trigonometric substitution, you are going to get another integral involving some other variables. And who's to say what the trick is to integrate the new integral? That is to say, it may involve integration by parts after that. That is to say, it may involve a trigonometric integral with powers of sines and cosines. That is to say, it may involve a trigonometric integral with powers of tangents and secants. We may have to proceed again. That is to say, it may involve a new substitution again. That is to say, it will involve a multi-step problem. So this trigonometric substitution with your triangle is just one step in a problem that may involve multiple steps. Now, when you see something like this in the integral, the trigonometric substitution that you are going to be required to make is this substitution here. Now you have to be very careful. And this is a very strange substitution. You are substituting for x. Whereas when you do a u substitution, you are substituting u. I'll make sure you understand the difference. That is to say, when you have something like this, you are going to make a substitution here. U is equal to 3x cubed plus 9x squared. So u will become the new variable. Whereas here, the new variable is theta. You see? So now it may not look like you are substituting theta. But you are. The new variable here is theta. Now, if you want to know really, the correct substitution is really there, but I'm not going to say that. X over a is the sine of theta. Why? Because then I can make my triangle very clearly. You make a triangle with the opposite side to theta, x, and the hypotenuse a. But I'm not. When you see something like this in the integral, the substitution you may want to make is x equals a secant theta. Now, when you see something like this one you have to be a little careful. You should try some things first. And if nothing is happening, then you will try the substitution. But I would say this is the last resort. I would say that would be a last resort. Now, of course, you must know your basic antiderivatives, and you must know your basic integration techniques of trigonometric functions, what we studied last week. You must know it very well. You must know that when you have powers of sine and cosine, you need to do u is equal to sine x, or u is equal to cosine x, or do a deflation with the half angle formula. When you have powers of tangent and secant, then you need to do a u is equal to secant or u is equal to tangent, depending on whether what is odd or what is even. If you have a product, then you need to convert it to a sum. And you also need to know that the antiderivative of 1 over x squared plus a squared is the arctangent or the inverse tangent. The antiderivative of 1 over root 1 minus x squared is the inverse sine. You must know these. This is what you would have learned in calculus 1. Let us take a look at one of these. A trigonometric integral, an integral, not a trigonometric integral, that involves the use of this substitution here. Now, these problems can be quite involved. They can involve many, many, many steps. So here's one. So this is per se not a trigonometric integral. But if you have listened to me, you will realize that you will need to make this substitution if you want to find the antiderivative. It may help you, it may not. In this particular case, it does help me, which is why I brought this paper. These are the problems on it, because I can't make these ones off the top of my head. So I'm going to make the, instead of making the variable x, I'm going to have to make the variable theta in this manner. Oh, you must know your trig identities, of course. You must know your trig identities. Sine squared plus cosine squared is equal to 1. 1 plus secant squared is equal to tangent squared. 1 plus cosecant squared is equal to cotangent squared, all that stuff. You must know how to make a triangle. What is the correct substitution here? That you see in the integrand, this creature appearing.
2 sine theta. X equals 4 squared.
X equals 2 sine theta. A squared minus x squared, a squared being 4, a being 2. You need to do a little bit of algebra. So the correct substitution is x equals 2 sine theta. Your next step is to immediately make a triangle. You'll make a triangle with theta what? What is theta? Theta is the angle whose sine is x over 2. Theta is the angle whose sine is x over 2, so that this is what? That squared minus that squared, take the square root. What is the next step? How?
Fine.
Well, the next step is to change dx. Because the variable is not x anymore.
Theta.
Okay, so how do I do that?
Really sense.
Huh?
Substitute all of the x's.
No, I need to differentiate.
Oh. 2 cosine.
Yes. dx by d theta is what?
2 cosine.
2 cosine theta, which is to say that dx is what? Cosine theta. So now I will come here. And write what here?
2 cosine theta.
1. And write what here?
2 sine.
Huh?
2 sine theta. theta squared.
Cosine theta. Then write what here?
Root 4 minus 2 sine theta squared.
What is this? 2 cosine theta, theta. And here we will write 4 minus what?
2 sine theta squared.
4 sine squared theta. And pick up 4, this will become 2 cosine theta d theta over 4 sine squared theta. I will take out the 4 and take the square root of it, it will become 2, and then I'll be left with root 1 minus sine squared. What is root 1 minus sine squared? Theta. What is 1 minus sine squared theta? Cosine squared theta. When I take the square root, I will get cosine theta. So I will be left with 2 cosine theta d theta over 4 sine squared theta times 2 times what? Cosine theta. And there will be a cancellation of cosine theta. Which will give us what? Two over 8, which is 1/4. What?
Sine. 1 over sine squared.
1 over sine squared theta d theta.